Ladies and gentlemen, welcome back. My name is Jeremy Champa. Today we're going to look at the October 2020 non-calculator section. Let's jump right in. So here's number 1. Remember, every time you see a paragraph, start with the last sentence, and we'll do that here. If Tobias was charged a total of $325, for how many days did he rent the kayak? Okay. Of course, some of these early questions, it may make sense to do them in a traditional way, but I'm just going to show you how to do it in the non-traditional way, which is take the answer choices and use them to your advantage. Since they're in order, which they always will be, in either ascending, sometimes, maybe they're always ascending, but it's either ascending or descending always. Take one of these middle two. Let's just take 5. And let's assume it's 5 and see how it works out instead of building an equation. Okay, so it's $60 a day is what we see here. So 5 days times 60 is $300. And then the $25 for delivery would bring us up to the grand total of $325. So I got a little bit lucky here, but answer choice B is right. Just to show you how it would work otherwise, let's say I started with C. $60 times 7 days would get us to, $420? And then if you added another 25, you'd say, well, look, that's already $445. That's too much. We wanted it to be less than that, so you know the two bigger answers are wrong. You go down and try B. Now, if B didn't work after I tried C, there would only be one logical answer remaining, so I would be done either way. So notice when you take this approach, you may only have to try 2 answer choices in many cases. Okay, so that's number 1. Let's do number 2. So which of the following is equivalent to the expression above? Okay, what I do on these questions is I try to divide and conquer. Now, don't confuse that with meaning that I'm doing division. What I mean is split the things up into pieces. Look, we could just deal with the last term first. That is there a negative or a positive 8, or is there nothing at all? Right? Like, what happens when we add these negative 4s and positive 4s? Of course, you would get 0. Well, that means right away that I can get rid of answer choices C and D, which have this negative or positive 8. There's no sign change, which is always something to be aware of, but that's not happening here. So that's out. Well, now let's just deal with the x's. There's positive 3x and then plus negative 8x is negative 5x. That's enough to finish this problem out. It's got to be answer choice A. And if I'm feeling a little bit shaky, I can use the other piece just to confirm. But look, every single answer choice has 5xy squared. There's no need to even do that work. It's present in every answer, so it doesn't really tell you anything about which answer is right, to be clear. Okay, so let's deal with number 3. I'm just going to get this stuff situated a little bit better for my setup. Here we go. Number 3, what is the value of f of 2? All that this means is if you have f of x equals 3 to the power of x, and you put a 2 in there, what do you get? So this problem is pretty straightforward. That 2 goes where x goes, and 3 squared is 9. So answer choice D is correct for number 3. So if you're confused about that, the big deal is that 3 squared just means 3 times itself. There's 2 3s. That's what we mean by 3 squared. 3 times 3. All right, moving to number 4. Zooming out a little bit so I can see everything. What is the value of f of 0, they're asking. And to be clear, I always like to write the number up here. If I remember, that's number 4. F of 0. Okay, so the big thing to consider here, look, on the SAT, a big part of your work is knowing what could easily go wrong and being, I don't like to say just being careful, I should say taking active measures to avoid that mistake. So the easy mistake here is XY confusion. And if you made a mistake here, don't just think, oh, that was a stupid mistake, I won't make it again. Think, okay, this is a common mistake for tons of people. There's nothing, shameful about having made that mistake. Just be aware that this is a mistake. Even if you didn't get this one wrong, you can learn a lot from the fact that other folks And many intelligent folks will make this mistake. So, of course, like we said on number 3, what we're talking about is the 0 is an x value. So when x is 0, it looks like we're down at -8 or -9. Let me just zoom in here and make sure that that value is -8. Yeah. And, there's this -9. What is that? That's the vertex, it looks like, because -10 is one spot below that. So -9 is the vertex, but we just want the value when x is 0. So, of course, the value when y is 0 is +2, which is an answer choice. So there's always a possibility of mixing up x's and y's. Be aware of that, and just the awareness that that's a thing will lead you to confirm. You'll probably end up getting the question right in that case. All right, so now we're on number 5. For what value of x is h of x equal to -2? Okay, so here, instead of x being a -2, we're saying the whole thing, h of x equals -2. Oops, -2. And so look, if h of x already equals all this business over here, then we could say -2, which equals h of x, equals the thing that h of x equals. I know that sounds linguistically complicated, but my point is h of x equals both -2 and h of x equals this thing. So they're both equal. Now there's an immediate thing that I would notice that could go wrong here, which is, it may be tempting to mess with these 2's, and you totally can. Subtract 2 from both sides. Just make sure you take care of that correctly. It'd be easy to shortcut it and cancel the 2's for incorrect reasons. This is -4 equals -4x minus 1. And look, I just kind of knew that my distribution, doing that first might not pay off. Do it when you have to do it. So in this case, the reason it paid off to sort of delay distribution is because now I'm not even going to distribute. Now I'm just going to divide both sides by -4. I get 1 on the left. -4 divided by -4 is 1. And then this is just x minus 1 now. So now x equals 2 when you add 1 to both sides. 2 equals x. And I was just kind of checking real quick, is that what they wanted? They want what value of x? Yeah, sometimes there's an extra step, and that'll happen on later questions probably. If you weren't sure about this, go plug 2 back into the original equation and see what you get. Right, -4, 2 minus 1. So that's -4 times 1 plus 2 is -4. I'm sorry, not equals, plus 2. And that's equal to +2. Oh, I'm sorry, -2. -2, which is what we want. So I just checked my work in a slightly different way than I did it the first time. Always see if you can, whenever you're working on this stuff in practice, see if you can figure out 2 ways of thinking about the problem, because on test day, you want to be able to check your work in a different way than you did it originally. If you check your work exactly the way you just did it, you may make the same mistake twice. It's unlikely that you'll make 2 totally different mistakes in 2 different approaches. I mean, it's possible, but it's just less likely. So there I sort of did it forwards and backwards to check my work. All right, we have this equation, a lot of information that I don't necessarily care about. We go to the end here. Which of the following expresses the temperature in degrees Rankine? In terms of the temperature in degrees Celsius, you can feel free to make fun of me in the comment section about this word that I don't know how to pronounce. Rankine or Rankine. Look, all we're trying to do is get R by itself. That's what the answer choices show us, and that's what the sentence says. So my process is to just peel layers away to get R by itself. This 5/9 is, in a sense, further away than R minus all this business, 491.67. First thing you would do is you would try to get rid of this fraction. So, of course, you could divide by 5/9 or multiply by 9/5. So when you divide by 5/9, dividing by a fraction is kind of goofy, but it's certainly doable. Dividing by a fraction is the same thing as multiplying by the reciprocal. So C divided by 9/5 is the same thing as C times I said that wrong. 5 over 9. And now c times 9 over 5. Right? So that's the same thing as if, I had just said, instead of doing this, I could have said multiply both sides by 9 over 5. Because 5/9 times 9 over 5 is just, you could do the math. It's 45 over 45, which is a 1. So you could do that to both sides too. Either way, however you want to think about it, you've actually done the same operation. It's just you've thought about it two different ways. You have this r minus 491.67. Now, maybe the convention would be to put the coefficient, that is the number multiplied by the variable c, in front of c. So 9/5 times c equals this business. So just writing it slightly differently. And then adding the 491. So look, I could say divide and conquer this question too, right? I sort of walked through it in a more traditional way, but I could have said, look, you're going to multiply by 9/5, so cross off c and d. And then you're going to add the 491, so cross off b, which says you subtract 491, and you're left with only one answer, which is a, right? When I did it, if I do it the traditional way, the step that I didn't do explicitly here was add 491 to both sides. 9/5 c plus 491.67. So just to be clear, because sometimes they'll write it two different ways. Look, 9 over 5 times c is the same thing as 9c over 5. Some people get a little bit confused about that. If you want, give yourself an easy number with c to make it make sense. Maybe try c is 10, right? 9 over 5 times 10. You could do that and figure out what that is as a decimal. It's going to be, it's not even a decimal. What am I talking about? That ends up being 18. Or 9 times 10 over 5. That's 90 over 5, which is also 18. So, doesn't matter how you write it. You may just want to be flexible with that so that the SAT may present it in one way. You want to be able to think about it in the same way that they present it, which could be different. They could write it as 9c over 5, which is different than they wrote it in these answer choices. Okay, let's take a look at number 7. I forgot to write the 6 here, so last minute, that's number 6. Okay, so here's number 7. The best interpretation of x in this context. So again, go right to the question. What is x they're asking? Well, it's whatever gets multiplied by 75. Right? It's whatever is getting multiplied by 75. That's kind of a wise-ass answer, but that's the way I approach these questions. When they ask me to interpret a part of an equation, I start with the most wise-ass answer. What is x? X is what gets multiplied by 75. Okay, well then look, it must be the thing it's attached to Aruba. And it's not the land area because the land area is 75. So look, is it the total number of residents in Aruba? I don't know yet. Is it the number of square miles? No, because I actually know what that is. Oops, that should have been a B. Is it the actual land area of Aruba in square miles? No, that's what 75 is. X is not 75. X gets multiplied by 75. Is it the total number of residents on both islands? I don't know why it would be that. Because X only has to do with this 75, which is Aruba. There's this whole other thing for Bermuda. And let's look at D. So now we have these two answer choices that are at least related. Something about Aruba. Well, look. It tells us that if we were to multiply 75 miles times X, and then add to that 19, which is a miles, times Y, it would give us the population, the total number of residents. Okay, so sometimes it makes sense to do a little analysis of your units. 75 is miles squared times X plus 19, which is miles squared, times Y, has to equal people. That means that this term must cancel the m squared with, maybe I'll use p for people. People over m squared. What is that? And that will happen here too. miles squared times y, which would be the number of people in 1 mile squared. That's what that's going to mean. So people, when you think of division, you can think of the word per as that division sign right there. People per mile squared, or square miles. Mile squared sounds weird, but it really just means square miles. People per mile squared is not the total residents, it's the population density. In residents, or people per division square mile of Aruba. D. Okay. So we're about halfway through the multiple choice, which means we expect that these questions are starting to get to the difficult stuff, or at least the medium level difficulty. Here's number 8. What is the sum of the solutions of the given equation? Okay. So there's a high likelihood that one of these answers is just one of the solutions as opposed to the sum of the solutions. This is a spot where oftentimes, and I don't know for sure, but the Eureka mistake. Eureka is, I don't know if it's current Greek or if it's ancient Greek, but it's a word related with when I think Archimedes came out and had this, he came up with this mathematical principle and he said, I've got it. Eureka. Eureka means I've got it. The problem is sometimes we do some work and we think we're done when we've solved for x and there's an extra step. So, this is a good example of, if you don't feel great about factoring, listen closely to how I factor this question, or at least try to. I think it's factorable. So you start by saying, okay, the first two terms have to multiply to be this guy, this x squared. So that's x times x. The second place you go is this sign. And all this sign tells you is, it tells you, first of all, because this is positive, remember, you're going to get 35 by multiplying whatever goes in this box by whatever goes in this box. That's how you get the 35. Well, if that's a positive value, then it means that's the same sign in both factors. And I'll write above this, if this is positive, because the only way you're going to get positive is positive times positive or negative times negative. You can't have a negative and a positive. So if you have negative and a negative, that's what we know so far. Because if you know that they're both the same sign, and this tells you that sign, what that sign is, right? So to be clear, if you had, it's not what we have, but if we had x squared and then a minus 35 over here, that would tell us you would have like a x minus and a x plus. That's the only way you would get this. And then if you had, say, like a positive term here, you would know that the bigger term is the positive one, because you end up, when you add these up, to be clear, the way you get the middle term is the most complicated. It comes from multiplying whatever this box is times x and whatever this box is times x and adding them up. Right? Some amount of x plus some other amount of x. Well, if you had a positive value here, so I guess how would I get this if I had a negative and a positive? Maybe I could get like a 2x here, for instance. What I'm thinking is I could have like a 7 and a 5. That would give me negative 35, and it would add to be 7x and negative 5x is positive 2x. So if you have this positive 2, you go, oh, the bigger one's positive. Right? Vice versa, if you have, like, I'll back up here. If you have like let me just get this super clean. A minus 2x minus 35. So if I were doing that, I would say, look, I need my x squareds, so x and x. This means I have two different signs, so I just put a positive and a minus. Doesn't matter which one's which. But then this tells me that the bigger one is negative. So I need a bigger number here and a smaller number here. And they have to multiply to be 35 and add to be negative 2. Negative 7, positive 5. So that's another example. Back to our actual question here, which is up here. When I'm factoring this, I would know that I have two, since I have a positive here, it means the signs are the same. This negative lets me know the signs are negative, and they should be what, a 5 and a 7, right? Since negative 5x and negative 7x would add up to negative 12x, and negative 5 times negative 7 would equal positive 35. So this means x equals 5. By the way, this is still equal to 0. That's the whole point. If x is a 5, it doesn't matter what happens here, because 5 minus 5 is 0 times whatever will be 0. Right? So over here, x is equal to positive 7 for the same reasons. If x is 7, you get a 0 here. 7 minus 7 is 0. And it doesn't matter what you get over here, because 0 times whatever is 0. Here's our two x values. In this case, they didn't have the eureka moment mistake, which is rare. But of course, the sum of these two answers of these two solutions is 12. Positive 5 and positive 7 gives us a 12. I mean, you might notice that that's just the negative b term, but if this was something other than a 1, then it wouldn't just be negative b. It's actually negative b over a. But that's kind of complicated, and there's no need to think that way for this question. You just got to do some factoring. By the way, you could also do the quadratic formula, right? So just to be clear, you could use, I'll write 1x squared because it's the same thing, minus 12x plus 35 equals 0. This is standard form, so this is the a, negative 12 is the b, and then 35 is the c. And you could use negative b plus or minus the square root of b squared minus 4ac all over 2a. And I won't bore you with all that work. Just as long as you plug that stuff in, you should still get the 5 and the 7. Okay, cool. So, number 9. Let's see. Okay, so, by the way, this drawing, it will look better on the real test. This document was sort of formatted. Somebody kind of put it all together, so thanks to whomever did that. It looks a little bit janky, but beggars can't be choosers. So sine, look, the big thing here is Sohcahtoa. So Sohcahtoa tells us about sine, cosine, and tangent. Sine of something is equal to the opposite over the hypotenuse. That's what this OH means. So if sine x equals 5 over 8, then the opposite side is 5, the side opposite from x, and then the hypotenuse is 8. So we want to know what's the value of cosine y. This is kind of a trick question that they really like. Cosine y would mean the adjacent over hypotenuse. So, you might think you have to go solve for this third side over here, but you actually don't, because what is adjacent to the y? Also 5. So the side that was opposite from x is adjacent to y. And here's the 8, which is the hypotenuse. So this is also 5 over 8. That's a time waster. They're hoping to get you to do some calculation and figure out that this is like, by the way you would do that is you would say, sort of the unknown thing squared. So let's call that, let's just use the question mark for now. Not very standard math form, but nobody's looking, right? Except the world. But when you're on the test, you could do whatever you want here. I would say using x's and y's or a's and b's would be kind of confusing because there's all that stuff already in the problem. So I'm just using Pythagorean Theorem here, and this says that, something that we don't know about squared plus 25 equals 64. You could subtract and find out that the question mark squared is whatever 64 minus 25 is. That's 39, 50, 64, yeah. And then this would be the square root of 39, but that's doesn't matter. I mean, it's in the answer choices because there's some mistakes floating around. Okay, cool. Let's keep going. Number 10. Again, the figure's a little distorted from what it would be on the real test, but that's okay. Which of the following could be the coordinates of point F? All right, so look, I'm going to take this and put it on the board, and I actually have a useful sort of bias on this question. I know that the SAT, when they deal with coordinate planes, I really don't have to calculate diagonal distances. It's a waste of time. So I'm not going to worry about doing the distance formula or something crazy like that. The triangles are similar. That means whatever this length is, and you could calculate it. Like, I'm not saying you couldn't calculate the length from D to E. Sorry, let me set this up. We'll need a little bit more space. You could calculate the D to E. It's just not very useful to do so because I know the test makers, and you can too. You can know that that is always going to be something that's not just the same length, but it's also going to have the same sort of vertical and horizontal similarity. So this goes down 2 and over 1, 2, 3, 4, 5, 6. So down 2 and over 6. So what I'm expecting here is to find one that's like down 1 over 3, and that's what we have here, even though it's a different direction. From A to C is that same distance. So then what we're looking for is, look, one of them goes, so that was essentially double. This triangle DE is going to be part of a triangle that's twice as big. And this was the key. This showed me 3 by 1 from A to C. That correlates with the, and we could have just used the points here. 6 is double 3. And the distance from -2 to -4 is 2, which is double the 1. So what does that mean? Well, let's look what happens from B to C. There's like we don't know which one, like we don't know if, do we know that, oh yes, we do know that A goes with D. And that makes sense because we already know that E and C go together. So that's the last one. When they say ABC is similar to DFE, they have to say essentially A is the same, is the sort of point that correlates with D. B is the point that correlates with F. And C is the point that correlates with E. So let's see. I mean, from C to B, which is the same thing as from E to F, it has to be like 2 away in each direction. So that means 4 away in each direction. So I could go like up here somewhere or down here. Looking at the answer choices, we all have negative y values. So I'm using those to my advantage. And I'm saying, if this is 2 and 2, then from C I should go down maybe 4, twice as big. 2, 3, 4. And then figure out what that point is. And then go over 4 more. 1, 2, 3, 4. So I think that would be, what, this point would be 4 units smaller than 8. So that's a 4. And then 4 units down from -4, which is -8. So I may have done something wrong here because I'm not getting an answer that matches what I was expecting. Let me kind of try from A and D. So from A and D, from A I go sort of 1, 2, 3, 4, and over 1. That means I should go maybe down twice as much and over 2. So down 8 units from 2. Down 8 units from -2 gets us to -10. And over, instead of 1 unit, over 2 units. So over 2 units would get us to 4. And then down 8 units. Well, let me just do this first. 1, 2, 3, 4, 5, 6, 7, 8. And then 2 units over. And we know that that point should be, like I said, over 2, so that gets us to 4, and down 8 gets us to -2. So let's see what I did wrong with E to D to F. Maybe I correlated these wrong. D, F, E. So F, E is the same thing as BC. Yeah, so that seems fine. Oh, I think I just did the calculation wrong. This is a 5. So I just did the calculation wrong. It should be, down 3 over 2. So now I'm going to go down 6 units from -4 yeah, this should have been, by the way, negative 10. I wrote it wrong. Negative 10. So kind of a mess out there. But hopefully you see what happened to me there. And there's something instructive about seeing the way that confusion happened. Counting all these points is probably not as good as just using the numerical values of each ordered pair. Right? So saying, 5 to 2, that's 3 units. 2 to 4, that's 2 units. So double it. Go down 6 units from 4 to negative 10. 1, 2, 3, 4, 5, 6. Go over 4 units because we went over 2 units and we're doubling it. 1, 3, 4. Here we go. So 4, negative 10. So I managed to make that kind of confusing, but I hope you can see, I mean, there is a lot to learn about the ways mistakes occur on this test, even for those of us who have been doing it for a while. So use the points to your advantage. Don't just do the counting thing. But I think both approaches are useful, right? So this was similar triangles, double the distances, and not worrying about the distance formula. By the way, just a little fun fact about the distance formula. It could be thought of as Pythagorean Theorem said a different way. A squared plus b squared equals c squared is the Pythagorean Theorem. And then, you could call this distance x1 or x2 minus x1. Maybe we'll write it that way. x2 minus x1 squared plus, you could call b the distances between the y's, y2 minus y1. And then what we usually do is take the square root of all of that and say that equals d. But you could just as easily say that equals the distance squared, right? So something squared plus something squared equals the diagonal squared, right? So we're not using the distance formula almost ever. I know it's tempting, but use the horizontal and vertical components. It's the better approach. All right, so number 11 here. Let me clear the board. Number 11. Okay, we want the y value of the solution. Okay, so in that case, look, in a lot of cases, it makes sense to not use substitution. They're kind of trying to force us to use substitution here. And I'm not going to fall for that trap. Just because, look, here's the normal approach. If y equals x plus 3, what people are usually going to do is they're going to replace y in the second equation. We have 2x minus y equals 0. Replace that y with the value x plus 3. You could totally do this. And in this case, it's just as efficient. You could add these up and get x plus 3. Right? 2x minus x is x. So now x equals negative 3. And you would think you're done. But of course, then what you have to do is you got to go solve for y. If x is negative 3, then y equals negative 3 plus 3, which is, of course, 0. You can take that approach. Just be aware that it's a common trap for people to, just pick the x value. It's right there. That's the eureka moment mistake that we were talking about earlier. Okay, but I'll show you another way just in case it comes up. Like, something that's very common is to see equations that are stackable. So, we have this 2x minus y business equals 0. I could very easily take our first equation and rewrite it as, first maybe I could rewrite it as, I'll put it over here, as y minus 3, or I'm sorry, let's put the x's and y's together like they are here. Y minus x equals 3, and then I could even write negative x plus y equals 3. Any of these are cool, but like on some questions, this is the best approach. I don't think it's necessarily the best approach here, but just to kind of show you what I'm doing. I just took this equation that I rewrote. I moved x over, and I wrote negative x plus y equals 3. I put these together. You could very easily, now that I've done this, cancel the y's, get 2x minus x is x equals 3. Just add these equations together. And let me make sure that I didn't do something goofy because I got two different answers. If y equals 3, then I think it's 6. So let's see. Let's see what I did wrong here. Again, so I've made a mistake that we could probably learn from. One thing I oftentimes tell folks is not to move the equations around too much. Oh, do you see my mistake? My mistake was distribution, folks. Because if y equals x plus 3, 2x minus y, this is why their substitution approach is so tricky and problematic in this case. Y should be replaced by x plus 3. That means that we have to distribute 2x minus x minus 3 equals 0. 2x minus x is x, minus 3 equals 0, x equals 3. So the traditional approach led me to make a very common mistake that I see with students. If you're going to have distribution in a problem, if it's like obvious that you're going to use distribution, be aware of the common traps. In this case, it paid off for me. So if x equals 3, to be clear, then y equals 3 plus 3. The x value is 3 and then plus 3 more, which is 6. So that's the right answer. My second approach, which was to try to do things in a non-traditional way, avoided that mistake. So just to be clear what I did, if I have y minus x equals positive 3, that's just me moving the x value over, and then rewriting it as negative x plus y equals 3. Now, when I combine the two equations, I have 2x minus y equals 0, and I have negative x plus y equals 3. And I could just combine these and figure out that x is positive 3. The eureka moment mistake is still lurking if we do it that way. One other thing you could do is try to cancel out the x's. Well, how do you do that? Well, what if we multiplied the second equation by 2? Everything by 2. The first equation stays exactly the way it is. The second equation becomes negative 2x positive 2y equals 6. The x's cancel. Negative y plus 2y is positive 1y, and that equals 6. This approach that I just showed you is called elimination. We're eliminating the x's because we know we're solving for y, as they ask for. In this case, it required more effort to set it up, but I think I just convinced myself that even when it's more effort, I think I'd rather do this approach because I made a mistake earlier, and I guess that mistake, I got a little bit lucky because there was no y equals 0 in the answers, which I'm just noticing. But I got a little bit lucky there, right? So if they had put y equals 0, I totally would have made a mistake. And I don't know why they didn't. In fact, that's very uncommon for the SAT to not take advantage of that kind of a trap. If x is negative 3, if that's a common answer, x is positive 3. But if it's a common answer to say that x is negative 3, then saying y equals negative 3 plus 3 would mean that 0 is a very likely mistake, right? So you saw me make a mistake with substitution, and instead I used elimination a second time. Okay, number 12. We're getting to the hard questions, but the hard questions are actually fairly predictable about the kind of things they'll ask you to do. So, for instance, I know right away when I see answers like this what's going on in this game. What's happening is we have this, exponential equation, but let's just pretend t is 1. If t is 1, what happens? Well, it sounds like A is the number of liters of fluid in a tank. So in 1 hour, A is going to equal 50 times 2, which is 100. Now they want to know what happens in 60 minutes. So just to start with, it won't get rid of all of our answers, but, this is 1 hour, right? And that's the same thing as saying M equals 60 minutes. And we know that's the exact same amount of time, so that we know that the tank's in the exact same place. So I picked 1 hour because it was super easy. I just had 50 times 2 to the power of 1. And that's just 50 times 2, or just 100. So now I know when M is 60, I need to get A equals 100. Answer choice A will do that. 52 times, if M is a 60, we have 60 over 60. That'll work. That's 50 times 2 to the power of 1. B will not work because it'll be 50 times 2 to the power of 60 times m, which is another 60, to the power of 3,600, which would be a massive number. C will work, 50 to the power of 2, or I'm sorry, 50 times 2 to the power of 60 over my m value, which is 60, right? So that's why A and C are the same right now. And D will not work because D will say 50 times 2 to the power of 60, which we know is wrong. 2 to the power of 60 is a huge number. Now, all I got to do is see what happens in 2 hours. When t equals 2, I'll do my equation more explicitly here. That would be A equals 50 times 2 squared. 2 squared is 4, so this is A equals 50 times 4. Remember, if you have this exponent, it's only applying to the thing in parentheses. 50 times 4, A will be equal to 200. So when t equals 2, that's hours. Minutes would be what? 120 minutes. So when you have 120 minutes, you want to get A equals 200. So go to answer choice A, see if it works. Well, is this what we get? Let's see, 50 times 2 raised to the power of m is 120 over 60. Yes, this will work. 120 over 60 is 2. You're going to get 50 times 2 squared. That's totally going to work. Meanwhile, C is going to be wrong. 50 to the power of 2, I'm sorry, 50 times 2 to the power of 60 over 120. 60 over 120 is 1/2. Now we're saying 50 times the square root of 2, or 50 times 2 to the 1/2. Definitely not equal to 200, because this would be saying the same thing as 50 times 2 to the 1/2, which is the same thing as saying 50 times root 2, and that's less than 100 for sure. I don't know exactly what it is, but we're trying to get to 200, and I know that 50 times 4 is 200. Right? This one, to be clear, was 50 times 2 to the second power. So that's 50 times 4, which is 200. So A is the right answer. All you got to do is make your exponents reasonable numbers that you can calculate reasonable values for. In this case, in 1 hour, the fluid volume is 100. When t is 2, the fluid volume is 200. And then you have, of course, 1 hour is 60 minutes, and 2 hours is 120 minutes. Cool. Moving on to number 13. They say, what could not be the value of k? Okay. It has exactly one solution. Think about what that means. Think about the left side and the right side. I have a lot of people say, well, it means, it works, or it works once. Yes, but that's not very useful, that information. What we're really saying is think about 3x plus 8 as one line, and then kx plus 8 as another line. Lines, of course, can do a couple things. They can either cross once, or they can cross not at all and be parallel, which means they have the same slope. Or they can be exactly the same line, just written two different ways, in which case they would have infinite solutions. Solutions mean intersections. That's a super important detail. Solutions mean intersections. So, look, if k was a 3, then we would have infinite solutions. And we want what value of k makes it so there's not just one solution. If k and 3 are the same thing, then we have infinite solutions. We have exactly the same line. That is not one solution. So k could be anything else, so that you have any other slope, right? If k is 0, then you just have the line y equals 8, right? That would have one intersection point. If k equals 1, then you have a less steep slope, and you'd start at, I guess, my graph was poorly drawn. If this is 8, I suppose, and my slope doesn't even look right. So let me kind of start from scratch here with a new, I lost my chalkboard. So bottom line is that if the slope were exactly the same, you would have multiple solutions. If the slope is anything different, I wanted to make sure I drew something fairly accurate. Let's make this an 8 and a fairly steep line. That's 3x plus 8. And then, if we had k is a 0, then you would just have the line y equals 8, which would just cross it that once. If you had the line, no matter what, they're all going to have the same intersection point, which is at 8, because they have the same y-intercept, which is positive 8. But, you could have like a really steep line if k was a value of 8, like answer choice D says. Or you could have, a slightly less steep line if k was a 1, as answer choice B says. We would have one intersection point in all three of these instances. The only way we have multiple is with this, if we have the exact same slope and the exact same line. So that would be the line laid on top of itself. Look, one other thing I would say about this is on your test, if you see the word not, don't just assume that you're going to remember it. A lot of people are going to mess it up halfway through. Like circle it a bunch or underline it. Do something to make sure you don't walk away from the question having picked something that gives you exactly one solution. Because 3 of the answers will give you one solution that's not what you want. Okay, so just to be clear, there's one other thing we could do here, was an algebraic approach. I just don't like it as much. 3x plus 8 equals kx plus 8. You could subtract 8 from both sides or cancel them out. Then you could divide both sides by x and get 3 equals k. And you would say, how do we, at that moment, it's kind of hard to figure out what we mean by one solution, right? Once we've gotten rid of the x's. So, you could stare at it and be like 3x equals kx. In order to make this not have infinite solutions, k and 3 can't be the same thing. But I think that approach is kind of confusing to think about. And it's easier to think about it in a graphic approach when you're talking about solutions. At least to begin with, that's what I do with solutions. Sometimes I have to do more, but that's the best way to start. So look, here's more solutions talk. How many solutions does this equation have? I don't know. Let's see. I mean, there's a couple things we could do. First of all, we could just, it's not absolutely obvious to me what's going on here. If it is more obvious, we'll find out soon. But we have x squared plus or minus 4x when I distribute that x term. And then I know that x minus 1 and x plus 1 is a difference of squares. I know that it multiplies to be x squared minus 1. But I'll show you how I'm going to get there. So if you FOIL this out, you get x squared. You get the outside term, which would be positive x. The inside term, which would be negative x. So that would be, positive 1x and negative 1x cancel. And negative 1 times positive 1 is negative 1. So we get x squared minus 4x equals x squared minus 1. Okay, so when we what I might do is subtract x squared from both sides, and so I can actually see what's going to happen here now. These cancel, and we have negative 4x equals negative 1. Divide both sides by negative 4, you'll get x is 1/4. That is one answer, right? Here's another way of thinking about that. Graphically, the first equation is x squared minus 4x, which implies something like a y-intercept of 0, and I think it goes like this. That negative 4x, I think, is telling me that we move in the opposite direction, I believe. Because the x value of the intercept, just a little side note, super important stuff on different questions. The quadratic tells you two things. One thing it can tell you is on the outside. I mean, it can really tell you three things, but you could think about it as two separate pieces. This outside piece is the x-coordinate of the vertex. So in this case, negative b would be positive 4 over 2a. Remember, the a is just this implied 1x squared. So just the 1. So negative b would be negative 4, which is positive 4, over 2 times 1, which is just 2. That's why my vertex is over here, where x equals. This is the x-coordinate of the vertex. I just figured out was a positive 2. So that's what that one looks like. And the other one, I know what it looks like. It's x squared minus 1, which means you start down at 1. And I don't know exactly where that would be, something like that. And then we're going to cross. And it's unclear to me if we cross once or twice when we look at that. right? Does it cross again here or not? I don't really know intuitively. I suppose maybe somebody does by saying, oh, it's x squared in both cases, so that means they're the same level of steepness. So no, they don't cross again. That doesn't occur to me as like super intuitive. The approach that I took, which was in this case algebraic, helped me out. So I told you sometimes a graphic approach is the place that I start on solution equations or solution questions. In this case, it just wasn't enough to finish it out. And I kind of saw that the graphs weren't going to be that easy for me because they were parabolas. So I took an algebraic approach, right? So once you've set up x squared minus 4x equals, when you FOIL this out, x squared minus 1, I knew how this was going to work as soon as I saw, oh, look, if I subtract x squared from both sides, I just get 1, right? So, or I'm sorry, when I subtract x squared from both sides, I just get this minus 4x equals negative 1. Yeah. Okay. Let's keep going. Once I see, just to be clear, once I see negative 4x equals negative 1, I just know there's one value that works for that. I don't even have to solve for what it is. I'm looking for not what is x, but how many values of x work, right? In the graphic example, it would be how many times do these intersect. In the algebraic setting, it's, how many times does this work? Only one x value will satisfy this equation. All right, number 15. N is a positive integer. Which of the following is equivalent to the expression above? Okay, so literally they just want us to move some stuff around. It's kind of weird looking. This might be a formatting issue. Oh, yeah, that's really goofy. 2 to the power of 2 over n times the nth root of 3. All right, look, there is a couple ways you could do this, and because some of the answer choices are radicals and some of them are fractional exponents, I have to figure it out both ways. So if I did it as a fractional exponent, it's 2 to the power of 2 over n times 3 to the power of 1 over n. Roots can be written as the denominators of fractions. Well, then what can I do? I suppose I could take n, the nth root of 2 squared, and then combine that with the, I'll break this down just a little bit simpler. This, I thought I was going to take a fractional approach, but I don't really know how to multiply. I can't do much with these because the bases are different. I would have to change the bases of the 2 and the 3, which I could make them, I guess I don't even really know what I could make them off the top of my head. 2 squared is 4, 8 is 2 cubed, then 16, none of these are powers of 3. 16, 32, still not a power of 3, so it may be really difficult to do that. It may be difficult, to be clear, if I had like a 2 and a 4, I could write, 4 to the 1 over n. I could write this as 2 squared to the power of 1 over n, which would then be 2 to the 2 over n, just multiplying 1 over n times 2, just multiplying this into the exponent. You could do that, and then maybe we could add the exponents. We could say, oh, well, if we have 2 times this business, now if they have the same bases, I can just add these 2 fractions together. If that's a little bit unclear, I'll circle back at the end of this question, but let's finish up what we're doing here. Since I can't change the base very easily, I'm kind of abandoning the idea of dealing with these terms. I'm kind of looking at the radicals here. What I'm thinking is I can rewrite this as 2 squared nth root, right? Pull this n out and make it a root. The denominator is a root. Multiply that by the same n over the nth power of 3. So again, this comes out just like it was to begin with. And then you can combine these underneath one radical. So that's 4 times 3, right? Just this becomes a 4 times this 3 is equal to the nth root of 12. There's our answer, D. So let me kind of show you another example that how this might work. If we had 8 to the power of 2 over n times the nth root of 2. Like, here's how this would work. You could do it exactly the same way, or I'll do it both ways. First, I'll do it the way where we make these both fractions. 8 to the power of 2 over n times 2 to the power of 1 over n. Then I'm going to change the bases. So 8 could be written as 2 cubed raised to the 2 over n, and multiply that by 2 to the 1 over n. Now you multiply this exponent in, you get 2. 3 times 2 over n is just 6 over n times 2 to the 1 over n. And now if you have the exact same bases, this is what I was getting at earlier, you can just add these exponents. So now that just becomes equal to 2 to the power of, 7 over n. That would be how you would do that question. Or if you wanted to do it back the other way that we just, for practice, the one we just did. So we could, one second. I could say this is the nth root of 8 squared. That is just me moving this n out. Times the nth root of 2. And then I could say that's the nth root of 64 times 2, which is equal to the nth root of 128. 64 times 2. 120 and 8. Yeah. Okay, cool. So that's just showing you some related information, but in this case, the answer was D. All right, and that's number 15. So now we're in the grid-ins, which are in no particular order of difficulty, is what I've found. Like, sometimes the first one's kind of tricky. Let's see what we have here. 1 second while I zoom out. Okay. So, what is the value of k, they ask. And they say this is a linear equation that represents the relationship of the table, x equals k. A linear equation that represents x equals k. Well, it seems like no matter what y is, x is a 2. I mean, if it helps to graph this, you certainly can. You could just draw a quick graph. Whenever I graph stuff, I don't try too hard to make it perfect. When x is 2, y is 0. When x is 2, y is 1. When x is 2, y is 2. It appears like we have a line. I can't draw that very well. Seems like we have a vertical line at x equals 2. So k is 2 on number 16. Okay, number 17. 12x plus 6 is equal to 4x plus 8. And they want to know what's the value of x. Well, this is just some straight up algebra. Subtract 4x from both sides. You'll get 8x. Subtract 6 from both sides. You know, these 6's will cancel. These negative 4x will cancel with positive 4x. 8 minus 6 is 2. Divide by 8 on both sides, 2 over 8. And you'll need to reduce, in order to get the points on this one, x is 1/4. And you could go back and try it again. 1/4 times 12 is 3. 3 plus 6 is 9. 1/4 times 4 is 1, plus 8 is 9. Okay, number 18. What is cosine B? Let's see. So, 6, 8, 10. Immediately, that should trigger your thoughts of 3, 4, 5. This is just a 3, 4, 5 that's been doubled. This is 3 times 2. I'll write an equals. This is equal to 4 times 2. And then this is equal to 5 times 2. Right? So that's a 3, 4, 5 that's been doubled. If this is a 12, it correlates with this 8. This is a 4 times 3. They want to know what's cosine B. Actually, we don't even need to do all this information. Cosine B, it doesn't matter if you're dealing a 3, 4, 5 or a 6, 8, 10, or in this case, it would be what? This distance from here to here would be 9, that's 3 times 3, and this distance would be 5 times 3, or 15. None of that matters because cosine B is adjacent. Remember, Sohcahtoa. So Sohcahtoa. Cosine B is adjacent, which is a 6, over hypotenuse, which is a 10. 6 over 10, adjacent over hypotenuse, 3 over 5. Whether it's 6 over 10 or 9 over 15, it reduces to 3 over 5. So we really didn't even have to calculate those other sides. That was sort of a compulsive move that a lot of us will pull, and I pulled in that situation, but it's unnecessary. Okay, so let's see about number 19. Okay, so no solutions. We talked about infinite solutions and one solution with linear equations. No solutions means they're parallel lines. They never cross. So the second equation, like we can calculate the first equation, and the second equation's got to be parallel to this. So the first equation, let's see, what do we know? We know these 2 points, so we can calculate the slope. The slope of the first equation, when I calculate slope, I try to do like it's rise over run, right? Rise over run, which is the change in y over the change in x, also written sometimes as y2 minus y1. By the way, it doesn't matter which is which over x2 minus x1. All that matters is that this is a point and that this is another point, and you subtract the two. So let's do that. For the first one, XY confusion is a big deal here. So the first one, the point 0, 4, put the 4 where the y goes, the 0 where the x goes, minus, minus. Then deal with this equation. So notice I just put this stuff in this order because I wanted to deal with 1 point. I didn't want to get mixed up. Yx, minus, minus. Then we have some minus signs here. The y value is -1, so -1. And then the x value is -4. So this would be 4 minus -1 is just positive now. That's 5. And then 0 minus -4. Sorry, my signs are getting a little bit sloppy here. This 5, I'll put a little bit further away so it doesn't look like it's -5. That's +5 and +4. That's the slope. The other equation has to have that slope too. Let's set it up in the form where we would know stuff about slope. So for instance, the other equation is ax minus y equals 1. And then I can say -y equals -ax plus 1. That was me just subtracting ax from both sides. Then I can times or divide by -1. Y equals +ax minus 1. And of course, this a is the slope. So what is the value of a? Well, if they're parallel lines, they have the exact same slope. So my value of a is 5/4. Right? It would be an equation with the exact same slope and a different y-intercept. The original y-intercept was a 4. Our y-intercept would be -1, and it would just be a parallel line sort of running from -1 parallel to this other line. So if I had time on that question, I would be checking my work back out. So I would just see if I have 5/4, and that makes sense to me because it's like this is a positive slope and it's not crazy steep. I could just count it. I could say, look, we go from -1 up to 4. That's a distance of up 5. And then over from -4 to 0, which is a distance of 4. So I feel confident that my slope, my m value is what we usually call it, is 5/4. For the second equation, I might just try out a as 5/4 and just make sure that I get the equation that I want at the end so that I didn't mess up a sign or something. So you could, if you want to do it a slightly different way, like I've talked about before, maybe move the y over this time. You can do that. So then you have this equal to 1 plus y. Subtract 1 from both sides. 5/4 x minus 1 equals y. Yeah, so the slope is right here. It's 5/4. Cool. So I checked it by using sort of a counting the gridded spots. Notice whenever I've done that, I use the second approach as well. I didn't let that be my only approach. Got me in a little bit of trouble on the earlier question about triangles, if you were with me for that. Okay. So what is the value of r? We're on number 20. Usually number 20 is kind of hard. By the way, number 14 and 15 are always considered difficult. 20 is usually considered difficult. The function can be written in this form, PRX. There's got to be some zeros I can use. Yes, x is 0. So for instance, we know if f of x equals PR raised to the power of x, we know that f of 0 equals PR to the power of 0, and we know what that equals from the chart. F of 0 is equal to 9. Okay, so this is useful because anything raised to the 0 power, anything, I don't know what r is yet, but anything when it's raised to the 0 power is a 1. So now I know p times 1 equals 9, aka p equals 9. So now I'm halfway home. We want to know the value of r. Well, look, I'll go to the next. I don't know if this will be the useful one, but I would start with this x equals 1 business because that's pretty useful. F of 1 equals the PRX thing, but P is a 9, R is still unknown, and X is a 1. And we know that that equals 12. So this just means 9R equals 12, and it means R equals 12 over 9, which is 4/3. Divide by 9, 12 over 9 is 4/3. If you want, you could try it out in the last point they give you. F of 2 equals 16. Well, let's just see if my work holds up here. If we have P is 9 times the R value of 4/3, and then that R value is going to get squared, raised to the x is 2. This is equal to 9, and then 4/3 squared is 4 squared over 3 squared, 16 over 9. And of course, 9 times 16 ninths. You could do the math, but 9 times 16 and then divide by 9, these 9s cancel and you just get 16. If you did the math, you would get 144 over 9, which is 16. Right? 9 times 16 would be 90 plus 54. Right? So that's 144 over 9. Cool. So that was just work to prove that I felt good about my answer, but I was done over here. R is 4/3. So I hope that was helpful. I will say that this section felt a little bit less heavy on some of the most useful strategies that I've seen, but notice, if you can, other questions that remind you of the questions you saw on this test. Like, I will say, as I scroll through just this quick little perusal before we call it a day here, look, there was a 3, 4, 5 question, right? This cosine thing where you didn't actually have to figure out the sides. That's pretty common. We had no solutions, which meant parallel lines. That's very common. We had this thing where the exponent value of 0 was very useful. R to the power of 0 is a 1. That got us going to figure out what P is, and we had to then solve for R. That's pretty common. This business of dealing with radicals as fractions, pretty common. One solution, the idea of a not question, and one solution thinking about lines being, in this case, not parallel and not the same line. Thinking about questions graphically in that situation. Look, x minus 1, x plus 1 is a difference of squares. That's very common. The idea of solutions here. This is a fairly frequent question that comes up about exponential equations and having fractional exponents. So what do? We made t a 1 or t a 2, some very easy numbers to work with because we knew that 1 or 2 for hours was going to equate to 60 or 120 minutes, right? So that's what we did on number 12. Backing up here, the solution to the equation, we saw a distribution error that I made here. We saw that elimination was a good approach, and we saw the eureka moment mistake because I believe x was 3. So it was really easy to pick 3, which is a eureka moment mistake. I've got it. I figured out what x is. There's one more step, right? The distribution error came from this minus y business. Minus x plus 3 meant we'd have to distribute that negative sign. This was a classic because number 10 required you to not think, didn't require you, but the best way was to think about vertical and horizontal changes from A to B and B to C and C to A. thinking about those as opposed to the actual distances, which will be kind of gross numbers. Seeing that the vertical and horizontal components were just doubled down here was a way easier approach to number 10, though I kind of made it a little bit harder on myself by counting the grids in a goofy way. This was a classic idea where cosine of one angle is the sine of another angle. If the two angles add up to 90 degrees, sine of one is cosine of the other. So some very common stuff now that I look at it coming up. The sum of the solutions. So in this case, not just what are the solutions, but what do they add up to? This interpreting equations question, where I start with a wise-ass answer. I say x is the thing that gets multiplied by 75, so it's not 75. Cross off answers from there. And I won't bore you with the details of everything else, but there were plenty of things in this test that seem like classics. So hopefully that was helpful to you. Definitely see if you can. It's a really good process to actually look through other tests and find questions that look like this. I could show you about 10 of each of these, but it will actually help you if you look through and find them yourself, right? So be active in your study, be active in your approach, talk to friends about these questions, work through stuff, see if you find another way or a different way you think about it. But remember, I've been teaching the SAT for, sad to say, 15 years. Only sad because it's sad to get old. I've been teaching the SAT for 15 years. These approaches that I'm showing you have been the ones that work the best for the most students. So I know that we're all unique and different, but I will say that for top scorers and for folks that are, trying to reach a more moderate goal, these approaches are the things that have helped all of my students, and there's been thousands of them. So I hope that helps you. Feel free to reach out and ask me any questions you want at any time. Comment in the videos, talk smack, do your thing, have fun, happy studying. Take care.